physics in the University of Oxford. Andrew did his undergraduate and doctoral degrees in Oxford. He then had postdoc positions in Paris and in Oxford. He has won the Maxwell Medal of the Institute of Physics, and he has very serious research interests in physics, quantum physics in particular, including quantum information and quantum computing. As a tutorial fellow, of course, he teaches a wide range of aspects of physics within the college, and within the university, he specializes in the teaching of atomic physics and laser physics. And he has an extraordinary range of publications. In physics, of course, including a book with the wonderful title, Relativity Made Relatively Easy, which he published in 2012, but also books on science, religion, philosophy, etc., including Faithful to Science in 2014 and Science and Humanity in 2018. And it's along that second line of inquiry that I believe he's going to speak to us this evening on the subject, Science and Religion, a Humane Future. Andrew, it's a great pleasure to introduce you. Over to you.
Thank you very much, Rick, and thank you everyone for, well, just joining with us, and I hope I will give to everyone a productive and creative use of their approximately 1 hour. I'd like to also just express my thanks both to the Rector and the Alumni Relations team for inviting me to speak, and I especially thank Amelia Cross, who made the arrangements. Science and religion, it's not an easy subject to address. Indeed, the very mention of those two words in the same sentence can cause a frisson of nervousness, or it may act as a cue for wry jokes around the dinner table. But I will try to encourage an atmosphere of openness as I speak. I'm going to use a PowerPoint presentation, which I will now just launch or show you. Let's see if that works. That one?
Yeah.
Okay, good. I hope you can see a picture of a boat and a title.
Yeah.
Now, the most difficult task in preparing this presentation has been that of selection. There's a huge amount one could say, so I've had to select what I think it best to include in a talk of 20 to 30 minutes. So I'll go through this outline in a moment, but I think it's also appropriate that I say that insofar as I have some expertise to draw on, I would point to maybe 30 years or so of considering these matters, and also 3 books with Oxford University Press, which the Rector just mentioned. I think it's also appropriate to underline that I've been a member of a church in the Christian tradition for all my adult life. So I want to say this so you sort of know where I'm coming from. So that is since approximately age 18. That has not been a straightforward decision, I mean, to maintain that membership, but it is a form of commitment which represents, for me at least, the requirements of intellectual honesty, among other things. Now, for the outline, first I will propose some basic points about terminology. Then I will proceed to the structure of scientific explanation, which will form the sort of main body of what I have to say. Then I'll add some simple ideas about words such as faith and reason and their interaction. We'll see about the timing. If I have time, I'll comment more briefly on some matters from history of science and religion. But we'll see how much time I've in the event have, and then I'll say a little bit about the future. So let's begin then with terminology. Science. Science is the organized study of the nature and mechanisms of the physical world. It involves experiment and theory together. And of course, there's a lot more one might say. Religion. religion is harder to define, but it is concerned with a communal sense of who we are and what we are for, what calls upon our commitment and nourishes our values. The word religion may also be used to refer to a specific body of ideas and practices. So you find people speaking of a religion or else religions in the plural. But today I'm primarily addressing the first idea, that is the religious sense in general, which is a sense of a meaning in the text of the world, one which gives us a role to play and a story to join in with. One might say that science is concerned with looking down and analysing, whereas religion is concerned with looking up and aspiring. What I mean by this metaphor is simply that different stances are appropriate to different types of activity. The difference between looking down on something we can dissect and looking up to that which calls upon us is itself a helpful distinction to make. Getting this clear can immediately help us to avoid many sorts of confusions. Now, I want to say also that I find the word religion to be, for me, an uncomfortable word. I have had to decide, indeed, whether I would be willing to call my own commitments religious or not. I suggest that a good way to handle this is to talk about not merely religion, but rather good religion and bad religion. I think we all know how terrible bad religion can be. And I hope we would also recognise the role of good religion in, for example, the history of reform of working practices, thinking about limits on the power of the state, and the origins of universal education, hospitals and hospices and the like. But I thought for today I'd show a simpler example of this distinction between good religion and bad religion. There's a conversation towards the end of the Gospel according to Matthew in the Bible, a conversation which has been very influential in Christian history, and it includes the idea of making disciples or followers. So now, what does that phrase "make disciples" mean? Is it persuade and require others to give their assent to various assertions about God? Or is it encourage others to live the sort of generous, radically egalitarian, open-hearted life which I have told you about and shown you? Well, I am going to leave this question hanging, but I know how I would answer it. Now, let me turn to the main body of what I'm going to talk about today, which is the structure of scientific explanation. Here I show the books which were mentioned earlier, and what I'm about to say is based on the third one of them, this one called Science and Humanity. Most of what I will say next is set out more fully there. So let's think about the scientific description of the natural world. I think that there is, lurking in many people's minds, perhaps not fully thought through, this kind of picture. So I'm showing you a sort of rough diagram which captures, as I say, for many people what they suspect is going on, but as you see from my statement here, this is wrong. But what people may suspect is science as a sort of ladder or a tower, with physics at the bottom explaining chemistry, which in turn explains biology, and all this in turn explains everything else, a sort of froth living at the top of the tower. There's a sort of hegemony of explanation with physics in charge, and then the whole universe becomes a sort of machine. Okay, so this picture is wrong, and indeed I can hardly overemphasize how wrong it is. Now, this bigger diagram is my attempt to show the structure of science more correctly. Now, it's not possible to do this fully correctly in a single diagram, but this does is a lot better an attempt than the sort of simple ladder or tower. So the main point about this diagram is you see I picked out a few areas, physics, chemistry and biology, which are here serving in for scientific areas in general. Of course, there are many more areas one could mention. And the main point is that they interact more, the interaction between them is more like a network rather than a tower. And furthermore, the interactions are two-way, not one-way. So in these little arrows pointing between physics and chemistry, I've written the word supports in one direction and then the word enarches in the other direction, a word which I've coined, and I will explain what I mean by it in a moment. I've also just alluded to other areas of human life here: poetry, art, music, law, history, and of course I'm not attempting to do justice to them all, but it's important that they are, you know, part of the diagram, and they each have their own appropriate discourse and ways of investigating. On the left, I've just written the word experience, which informs all of these. And at the top and bottom, you've seen I've used the words glorious mystery, simply alluding to the fact that underpinning all of our understanding of the natural world, ultimately there is a mystery about it. We don't really know how anything manages to exist or how it came about in the first place, nor do we really know what all of our efforts at poetry, art and the like are ultimately about. You know, we continue to make progress, and we aspire to realizing a more and greater expression of human life as we go on. But of course, there's a great mystery there as well. So this is my then attempt to place the structure of science, or capture it more carefully. Let me now tell you what I mean by this word enarches. I use the example of physics and biology to illustrate. So first of all, the left arrows, physics supports, meaning can physically embody an expression of what goes on in biology. Meanwhile, biology is a set of ideas which has its own appropriate discourse and has many ideas which live sort of among themselves coherently. And they sort of, in my phrase, enarch over the framework supplied by physics. So biology exhibits the structures and behaviours that make sense in their own terms and are possible within the framework of physics. Now, let me illustrate this. My first illustration will be quite simple, simply a stone arch. So this picture shows us a stone arch, and you see the two arches, and it's made of stone, and I dare say there is mortar as well between the stones. So that if one wanted to understand this bridge, and particularly the nature of the arch, one would include study of the individual stones. And one might, after studying stones and mortar for a while, one might consider that one had arrived at a thorough and complete understanding of an arch. After all, there's nothing else there but stone, or stone and mortar. So if we understand stone and mortar fully, have we then understood an arch? Well, the answer to that question is no, not necessarily, because after all, an arch could equally well be made of some other material, such as wood or iron or steel. And the point here is that the arch is a certain shape which has generic engineering properties to do with its overall shape and the way it distributes force. So that although it's perfectly correct and appropriate to unpack the individual stones here, or the material of which the arch is made, they in and of themselves do not tell us the whole picture of the nature of the arch until we have also got an understanding of the overall global properties. And what's interesting to note is that even if all arches everywhere were made of stone, it would still be false to say that arches are explained by stones. Because, I repeat, we don't require stone at all to have an arch. There could equally well be another material. So this illustrates this notion of different contributions to an understanding or a description. I'm now going to extend this to areas which in the first instance will be mostly in the science called physics, but then I'll go to other areas. So this next example is about the use of an idea which we call symmetry principles when we study physics. So symmetry principles are statements about types of equation or types of behavior. And I've here just listed a few examples. Now, some of you will know the technical language here and others will not. It's not important that you know the technical terms, but you just get the idea that there are a number of different principles that work in physics that go by names such as translational invariance, the principle of relativity, also named after Lorentz. There's general relativity, and there are more: charge conjugation, parity, thermodynamics. Okay, so I'm going to illustrate the first of these, the one I call translational invariance. Now this is a statement about the nature of the sorts of physics that goes on in many everyday processes, and I'm going to use the example of a motor in a car, or the engine in a car, to illustrate. The principle of translational invariance simply says that the motor will work the same way no matter where the car happens to be. If you translate the car in the sense of move it from one place to another, that won't affect the internal dynamics. Everything will still work fine. So this is an interesting insight into the nature of car engines in general. But suppose we imagine an engineer who wants to resist that insight. Imagine they might take this point of view. Look, here is the equation of motion, says our hypothetical engineer. The force causes the piston head to accelerate, and the force is given by the formula for pressure in a hot gas. And that's it. That's all we need. We can find the solution for given starting conditions, and then we have everything. The symmetry principle you mentioned, translational symmetry, or whatever it was, that is completely irrelevant. It has no role at all. I have no need of that hypothesis. So what should we say to our hypothetical engineer? Well, we can reply as follows. If we start from the principle of translational invariance, that will then tell us overall properties of the types of equation which are needed. Now, here I've just written some technical terms. The symmetry tells us the mathematical form of the energy, which is kinetic and potential energy, and that it must be independent of location. And from this, in turn, the equation of motion follows. So the very equation which the engineer wished to appeal to itself follows from, or rather the nature, the general type of equation itself follows from the symmetry principle. So the symmetry principle is not an afterthought. It rather underpins the insight right from the start. And this proves to be much the more insightful way to see the relationship. Now, I'm going to have to, as I said, I've had to be selective today, so I'm going to immediately move on and just show you a few more examples of symmetry, but this will go quicker now. So those of you that have some training in physics will recognize the equations I'm writing here, but you do not need to know these equations. You can just hear what I have to say about their implications. So when we study electromagnetic phenomena, we have a bunch of equations which are quite complicated, and they lead to predictions about what physical objects will do. For example, they predict that physical objects will contract when they move very fast. But that same contraction can also be deduced from a symmetry reasoning. So we just quote some very general symmetry principles. This is Einstein's work of 1905. And from that, we derive, by a much more direct and insightful argument, the contraction, which otherwise we would have had to deduce by a very lengthy mathematical analysis. So this is an example of symmetry going right to the heart of the problem rapidly. But again, someone might argue that given the equations of electromagnetism, surely the principle of symmetry here just follows from the equations. Well, again, how do we reply? This is the argument. Is it the case that the symmetry principle somehow does not add anything, does not introduce any new insight into electromagnetism? And we reply by arguing, no, on the contrary, if we start with the symmetry principle, we can in fact derive the equations of electromagnetism. So far from not adding anything, what the symmetry here does rather is it has already added everything from the beginning. Really, my aim here is to persuade you that this type of reasoning is not, there are two types of reasoning going on in fundamental physics. And my point is not to say that one wins and the other dies. My whole point is that both are relevant, both are insightful, and they live together. And that is the nature of the structure, at least of explanation in fundamental physics. Now, I have today argued that similar relationships go on throughout the sciences, but I don't have time to spell them out in full. I just here allude to a few areas of chemistry or at the boundary of physics and chemistry. So fluid mechanics, thermodynamics, reaction networks, organized criticality. And I remind you of the overall picture. So of course, I'm arguing similar things about the relationship between physics and biology, but I'm not spelling them out in full today. But when we talk about science and religion, it's important to have a few comments on evolutionary biology, since that has proved to be one of these areas that has for a long time proved where tensions have arisen. So let me say a little bit about that. Now, one way which people want to present this, which I'm questioning, but this is a way which has been presented, is that if we take the standard story from mainstream biology of the picture of Darwinian evolution with natural selection, genetics and variation and so on, people have argued that this implies a pitiless natural world without direction or purpose. People have also tried to get other things out of evolution, which I'm not going to go to. People have, in the past at least, argued for eugenics on evolutionary grounds. But of course, that I hope at least we've seen that really doesn't follow. But this implication, the one I've set out here but queried, is I think still live. It's still what a lot of people are arguing. So in reaction to that, what some communities want to do is say, OK, well, if standard evolutionary biology implies a pitiless natural world without direction or purpose, then surely standard evolutionary biology must be wrong. OK, this is one reaction. But it's not the reaction I take. I want to argue for this reaction. It's the implies which is wrong. So standard evolutionary biology, at least understood correctly, does not imply a pitiless natural world without direction or purpose. So let me unpack that a little. Let me consider this proposal, which I'm now going to question. So the proposal that evolution is blind, not guided or part of a design, and as such has no goal or purpose. It is just a more or less random sequence of mutations and environmental influences. OK, so I'm going to query that. Let's look at an ordinary tree. Here's just a picture of a tree trunk. And if you look at the cross section of the tree trunk, it's this shape, approximately circular. I mean, it's not a very elongated ellipse. It's not a triangle. It's not exactly a circle, but it's approximately circular. And if I look at some other tree, I will also find the same. But what about another living thing? Here's a little beetle or whatever that is. Look at the shape of the antennae. The cross section, oh, look at it, it's a circle. What about the bones of a mammal? The cross section, well, it's approximately circular. So is this all sort of random? Is this some huge coincidence? Well, of course not. The reason that all these different shapes are approximately circular is that the circular shape makes efficient use of materials for the purpose of gaining a given overall mechanical strength or other properties. And my point is that truth, that the fact that the circular shape makes efficient use of materials, that's not a truth that's to do with genetics or the way genes behave. It's simply a part of engineering science. It's almost a part of mathematics. So the evolutionary biology did not, in this example, simply achieve a random result. The result was there waiting to be exploited. It's there built into the very nature of what materials are, the nature of the physical world. So results of this kind are not random. And once you've begun to see this simple example, of course, you can immediately find a myriad other examples of the fact that evolutionary biology is not altogether random. Of course, there's a random element, but here are some other outcomes which are not random. So fast swimmers have smooth bodies. Of course they do. Large animals have strong muscles. Hearts generate enough pressure to circulate blood. Compressive load-bearing structures have efficient shapes, such as arches and columns. These things are all seen in many different animals and plants. But the point now is we continue this onto other more higher level insights, such as social dynamics. Now, what goes on amongst species that can have social dynamics, such as whales and elephants, has a certain commonality. the social dynamics in a pod of whales has much in common with what goes on in elephants, and of course in humans ultimately as well, although human society is a whole lot more complicated still. But is it the case that what we now have in our human society could have been utterly otherwise than it is, and it is simply a random outcome? I'm arguing that no, it's not a random outcome, and I'll give you an example of that. Human reasoning about number. So we consider that numbers such as 2, when added to 2, make 4. And that's not a random outcome. It's not possible that we could have decided that 2 plus 2 makes some other number, like 7. The point is, mathematics has an internal logic of its own, which we either discover and come to understand or not. I mean, if we never understood it, then we would simply not understand what I'm even talking about. But if we understand mathematics, then mathematics is what we understand, and evolution had nothing at all to do with that. It could not influence the shape of mathematical outcomes one way or the other. And I would argue that similar claims can be made about moral considerations. All right, so this is a more debatable point, but I'm going to make it anyway. When we come to moral conclusions, and I've given an example here, the conclusion that judges ought not to take bribes. Okay, so a simple idea, but one which includes the word ought. I put it to you that that's not a conclusion which is just a random outcome. Rather, that's an insight into the very nature of what it is to be a community which aims for fairness. Okay, so this is my point about evolution then having a random component and yet being very far from random, or without any sense in which it could be said to be guided. It's not guided, I believe, in a sort of direct, this is what you must do next sort of sense. It's guided more in the nature of the very way that things can be. You cannot have a fair human society in which people are taking bribes. So if you want to arrive at a fair human society, then a fair human society is what you have to arrive at. Okay, well, I'm beginning to repeat myself, so I must move on. Now, I'm also beginning to come to the end of my allotted time, so I will now aim to finish in the next few minutes. Okay. Now, I'm now just going to say briefly some ideas about terminology. Again, now this will go very quick, and it's because I want to point out that the word faith is another one of those words which has been squeezed into different meanings by different groups of people. So I want to say what I think it ought to mean, or what the word faith captures, what that word is about. And I do it by giving an example from everyday life. Here is just some people shopping in a shop. Now, the word faith is captured here because what goes on when we go shopping is that we enact a relationship with other people that we don't necessarily know very well. So these customers here may not know the person at the till particularly well, but the customers are prepared to trust that the person at the till is doing a reasonable job of getting the prices and not sort of adding a few extra pounds here and there to the total bill. Meanwhile, the person at the till is willing to trust that the customers on the whole are not putting a little extra chocolate bar in their back pocket, meaning the relationship goes more smoothly and more fluidly because there's an element of mutual trust going on that's beyond what anyone has proven carefully to themselves, but which nevertheless has an undercurrent of reasonableness about it. Okay, so that's what faith is like. Faith is not belief without evidence or reason. It's something which is motivated, but it does have an element of willingness. So faith is really a word for willingness or eagerness to go further. Okay, so is faith then sort of an alternative to science? No, it's not. It's more like this. Faith is a way of thinking about the way the whole of one's life comes together, whether it's with arts and science together. And similarly, is faith an alternative to reason? No, faith and reason are not the same, but they can meet together and work together. And I'll just finish with an example of that. So here is this distinction between irrational and rational. So an example of an irrational statement would be a copper bracelet will protect you from rheumatism. and irrational because there is no good reason to think that that would be true. A rational statement might include a simple piece of reasoning. If the tomb was empty, then either the body was never placed there or something happened to it. Okay, this is just using our reasoning capacity. But I want to say that faith includes that and embraces it, but I admit does go further. So what does faith do, or how would we illustrate it? I illustrate it by this statement or question: will you marry me? Okay, this just illustrates the sense in which faith does have a support from a sort of a sense of what would be reasonable, but it's willing to venture out and go further than reason on its own can carry us. Okay, so of course, no, I don't want to say too much, so I'm going to skip that and I'll skip on to the end now. I think what I feel I've been doing in this last part is saying a little bit, I'm just returning to my diagram. I've begun now to say a little bit about the top and bottom of my diagram, where I used the simple phrase glorious mystery. And I've touched on a little bit about what goes on in the context of religious faith. But of course, I acknowledge I've not said much about that. And I think the timing is such that it's best if I finish there. But by all means, I'm welcome to have questions from any sort of area or from any viewpoint, whether concerning what I've explicitly touched on or other things that I could have said but chose to leave out. So thanks very much for your attention, and I'm happy to have questions.
Thank you very much, Andrew. Really amazing exposition of some very difficult concepts and weaving them together. May I now invite people in our group here to use the hands up function on Teams in the upper right, the toolbar in the upper right-hand corner. I see we have a question from Matthias. Please unmute yourself and ask your question.
Hello, Andrew. It's
Hello,
very
Matthias.
nice to see you again.
And you.
I'm so happy to be part of this talk and to hear you speak. I'm just wondering. Sometimes people ask. Sometimes people say that the miracle of Jesus is not space-time invariant. Do you have any thoughts on that claim?
I'm not quite sure what the phrase even means. Try and say it again. It's slightly more length.
Well, it's sort of something like saying, well, some of these people were lucky enough to witness the miracle of Jesus, but it's kind of contingent. They were living in a certain place at a certain time. Does it sort of say something about something that we should care about in other places of the universe at other times as well?
Yeah. Fine. So what I hear you asking, Matthias, is concerning the sort of nature of how we might respond to the life of Jesus of Nazareth. Now, I want to acknowledge that we all have the right to receive what has been said about him, with every effort we can bring of making sense of it correctly. Now, what I'm trying to say there is that for me, we must acknowledge that he's first and foremost a fellow human being for whom there is good historical reason to believe that he lived and said broadly what is written of him. I don't think we need to assume that the biblical account is precisely correct in every detail, but I think we can take it to be an honest account. Now, we then touch on the fact that what is claimed of him does extend beyond the ordinary processes of human life. That there are things said to have happened which are correctly called miraculous. And now we enter into a whole, big issue of, so are we to say that the best explanation is simply that people in those days were more ready to see things that way, and what really happened was not miraculous, or it actually something correctly called miraculous actually happened? Now, my own view is the second one of those, but I don't say that lightly. However, if something miraculous happened, miraculous, I mean various things like that, unique, significant, significant for what it tells us about our own humanity. Now, if it has those qualities, then it is relevant at all times, even if it only happened, in one time and place. It immediately has inescapable relevance to all other times and places, if it happened as it's claimed to have happened. But if it didn't happen that way, oh well, then its relevance is much less important, of course. But has that answered your question enough?
Well, yes, sort of part of it. I mean, part of it is also to do with fairness. Is it fair that God should show his power to humans in this way through demonstrating this miracle to only some people, but not to everyone?
Well, I think what we should do with this is, I know that I can't speak for too long on one question because there may be others who need to come in. I think that on that business of fairness, the way I see it is that those that see themselves as a community that maintain a witness to what we as Christians claim Jesus represents, it's our sort of role and job to make sure that it is fair. And of course, the Christian community has singularly failed to do this, except with honourable exceptions. But if that community does in fact embody in the world what he stood for, then it will be very clear that what he stood for does have this bigger relevance, and therefore it would become fair that way. That's how I see it anyway.
I'd like to call on Hugh Wybrew now, whose hand is up. Hugh, would you unmute yourself and ask your question?
Yes, it's not my hand that's up.
Ah, okay.
Sorry.
That's fair enough.
Unless I clicked by mistake.
My monitor is defective then. Ian Laurie.
Yes, have I unmuted myself?
You have.
Yeah.
Thank you. Well, first of all, Andrew, thank you very much for an interesting and thought-provoking talk. I wanted to ask you about when you talked about the slide that you've still got up, in fact, evolutionary biology. You didn't mention what a lot of people would think is central, which is the principle of natural selection and fitness to survive.
Yeah.
And it seems to me that once you think about that a bit, if you want to have things that are capable of reproducing themselves, then fitness to survive is going to explain most of the things that you thought needed to be explained. And it also seems to be consistent with the picture that you've got on the right-hand side of a pitiless natural world without direction of purpose. So I wonder what you have to say about that.
Okay. Yeah, we appear to have slightly arrived at cross purposes there. My point is that natural selection is, after all, simply, it's almost a term for a tautology. It says that organisms which have a greater reproductive success have a greater reproductive success. I mean, it's sort of just saying that, isn't it? So my point is that natural selection is just sort of pointing us to that fact. And but it doesn't. Well, but the point is, what is it about the structure of a given organism which enables it to have greater reproductive success? And for example, I gave the example of the fact that if its morphology, its shape includes things like round rather than triangular, it will find itself faring better in the world. And so my point is that why would we argue that the whole process is without direction when it could not avoid discovering and exploiting truths about the way things are rather than untruths? So a truth about the way things are is the efficiency of some shapes compared with others. So that truth is there, as it were, inescapable, like a mold, which if things want to have shapes and fare well and reproduce, they can't avoid having efficient shapes. So do you see, the point is then not that natural selection didn't happen. Natural selection did happen, but but the outcome is not random. There are no triangular trees in the world. Now, I didn't talk much about pity in my talk. I used the word pity, and I said that the world is not pitiless. Well, plate tectonics are pitiless. You know, things like volcanoes are pitiless. They don't have any capacity for pity. So where is the pity to be found in the natural world? Well, it's the only place it could ever be found, and that's in the higher organisms, such as ourselves. And there it is found. So I'll just make that point.
I'd like to call on Henry Brown now.
Yes, thank you. Thank you, Andrew, for a very interesting talk. I was a chemist when I was at Exeter College, a long time ago, and I was not a Christian at that point, and I became a Christian quite late in life, in my 60s, in fact, and started reading the Bible and was more or less convinced by the stories there about Jesus. I'd like to take you back to the question of miracles.
Mm-hmm.
And, for example, the raising of Lazarus, who had died and was well known to have died and had died for several days before Jesus turned up and raised him from the dead. Now, how do scientific principles, I'm not saying explain that, but what do scientific principles have to say about miracles like that?
Yeah, well, thanks. I think the background there is that really science in its very nature is a set of tools which we use to more fully grasp those parts of the physical world which are reproducible and are its ordinary, which embody its ordinary nature, what goes on almost the whole time. And of course, if you think that there are no miracles, then you would say not just almost the whole time, but the whole time.
Yeah.
So science then simply does not have the tools to unpack what really went on if indeed Lazarus was raised. Now, I think Lazarus was raised, but I admit that another person will take that same account and think that no, on the contrary, it's a sort of pious attempt to express truths that are important to the writer and the community writing it. This is the other way of seeing what goes on there, and that's what we should make of that account. Now, but so why do I not take that other view? And it's, of course, as I'm sure it is for you as well, it's based on a very large number of considerations, and there's no quick way for me to put them all. But that if indeed Lazarus was raised, had been dead and was raised, then science can't really, science simply is not the means to add much to that, to sort of unpack it much. All that science can do for us there is remind us that such events are indeed utterly extraordinary. But I guess we sort of knew that already. I like the illustration that C.S. Lewis used when he appealed to the example of timetables on the railways. Okay, so the railway timetable sets out how when trains will ordinarily run. And similarly, science will set out what goes on in the natural world almost the whole time. But in the case of the railway timetable, there may be exceptions. And some of us think that there can also be exceptions in the natural world. But science cannot show us them, just as the railway timetable, it's not designed to show the exceptions in the case of the planning of the trains. Anyway, there we are. That's what I think.
Okay, thank you.
Ian West.
Oh, Congratulations, a very bold, a very courageous, very rational and helpful exposition. Thank you. I think you probably are familiar with the point I'm going to make. You said that pity does exist, I agree, and does exist where you'd expect to find it in the higher animals. I agree. I think it's been discussed a lot by mathematicians, mathematical evolutionists, that Darwinism can produce altruism in the strong sense that the person who gives his life or gives his goods for the benefit of others can actually survive if those others are kin. This is a big subject, but my further point is that I think you've almost painted God out of your religion, in that you the tree is round for a given reason, not because God said so or anything. The altruism exists for a given reason, not, you know, and the bridge is an arch and so on, and symmetry exists and so on. So I've got a further point. I might send you my book.
No, okay. Thanks for that. I think that, first of all, I agree that there are perfectly sensible Darwinian accounts of how things like altruism come about. I think that's not yet fully understood, but certainly there is good reason to point to some examples that have that Darwinian background. And I want to remind you that my perspective is not one which tries to argue that something other than Darwinian evolution happened. I think Darwinian evolution did happen. My point was simply that the nature of the world and the life that has resulted is not, in fact, a pitiless world. It is a difficult and painful world, but it's one full of meaning. And nor is the outcome of Darwinian evolution merely random. And that's what enables me, at least with good rational credentials, to make the claim that it is not without purpose. Now, it does not prove that it has a purpose. The logic is that if the process had been merely random, I think it would be impossible to claim that it was purposeful. But given that, in fact, it was not random, it's open to us to see a purpose being worked out in the world of which we are a part. That's where the logic goes for me. Now, your further point about, am I, as it were, painting God out of the picture? I find that a very helpful remark, because it opens for me just the opportunity to say a little bit about how God is in the picture, at least for me. But now this, I want to admit, is a subjective thing to do. And I just bring, along my sort of witness, if you like. So obviously, in my overall picture of the structure, I use the phrase glorious mystery, partly in order that my approach might at least be fairly open and not immediately tied down too closely from the start. That glorious mystery is appropriately named God, in my opinion, because by using that name, we affirm a sense in which there's a personal aspect to the relationship between ourselves and the mystery, which certainly is there. I mean, there isn't any question about the fact that we do indeed find ourselves caught between these two mysteries of why there is existence at all, which we cannot ever, account for fully. Nor can we fully account for what we are all about and what we're for, if we are for anything. So these things do remain mysterious. But what I bear witness to is the notion that our lives are more fully and creatively realized when we open ourselves to the notion that God interacts with us partly in personal terms. So by that I mean it's correct to say of God that God is love. But what am I even saying when I say that? I hardly know. But nevertheless, I would say it. When we take a moment to sit in silent contemplation and learn how to do that fully, we may, if we choose, make ourselves open to the notion that we may be known by God. Rather, it's not just about us knowing other things. There's a sense in which we are known. It's meaning a two-way relationship. So, yeah, my experience is that if one makes oneself open to the notion that there is a two-way relationship, then such a two-way relationship can be what happens. But I don't claim it to be simple to describe or anything like that. And I admit that this language is itself risky. It risks inappropriate behaviours and all sorts of things.
Can I follow that up?
Yeah.
Only briefly. I've got somebody else waiting, but please do have a quick follow-up.
My book is called God for Atheists, so you see
Okay.
what applied. And I'm going to ask if you're a Quaker, because almost everything you've said fits.
Yeah, okay. Well, I have a lot of sympathy for what the Quaker movement represents, but I have to say I have a good deal of sympathy for most long-standing cultural movements in the world, including atheism and secular humanism and Eastern Orthodox, and many of these cultural traditions have found ways of offering a way of communal life which enables people to flourish. And the Quakers have done that, and so have a lot of other groups. So yeah, I'm not myself a Quaker, because I think what the Quaker movement perhaps risks is it, for me, has a little bit too much reluctance to come right down and really affirm something and say, concretely, we think, well, for example, something that I think, that Jesus was raised to life after he had been killed. That's not something I believe, in inverted commas, meaning it's not something I just sort of guess at. It's something I consider to be so, and I've got my reasons to think that. But I think the Quaker movement is a little bit hesitant to really come right out and really say stuff sometimes, insofar as it has weaknesses, but it has many strengths. Anyway, but I can't speak for too long on one question, but thanks for that.
Adrian Neal.
I think the question I was going to ask you've partly answered, which is, have you argued God out of it altogether? Because it seems to me that what you said right from the beginning in terms of the definitions doesn't mean to imply any religion at all. It could just be a humanistic explanation of human behaviour and the way the world is. Could I go on to something a bit more tangential, perhaps? When I was at Oxford, I learned that in psychology that human consciousness is the outcome of processes in the brain, and without those processes, there is no consciousness. And that strikes me as a fairly plausible thing to believe. What I find less plausible is that at the point of death, some non-physical entity leaves the human body, which I assume is what Christians believe, and goes somewhere else. So it's really about the nature of human consciousness.
Yeah, thanks. Okay. Well, I guess maybe some Christians think of this sort of, as you put it, a non-physical entity that leaves the body, but that's not the main central view from historic Christianity. Historic Christianity is very much trying to make sense of what we call the resurrection, and also to bring in a hope for a resurrection of pretty much the whole natural order. So what we think happened in one particular individual case, we see as a sort of a hint of a spring, the first sort of little signal of a springtime. So that as I say, the mainstream Christian view of this is not so much about bodies that contain souls and the souls sort of go on their own way. It's rather that the soul is a name for that which it is that makes you who you are, body and all, and that's who you are. And the notion is that we are known by God, and We do not claim to know for sure anything about our life after this, but we have just this rather marvelous but important hint in what we think happened in the case of Jesus. And we think that something like that is going to be the destiny of the whole natural order, you know, not just individual people. Anyway, it's a huge claim, but it's not about, well, there we are. I don't know whether that at least got conveyed to you a sense of what it is that Christianity has on the whole stood for.
I'd have thought that most Christians believe in the nature of the human soul, and that seems to be very widespread in modern church teaching.
Yeah, but what does the word soul mean? I mean, unfortunately, people are not always very clear to spell out what they think they mean by it. Yeah,
most people, most religious people, not just in Christianity, seem to think there is some afterlife in which that human personality continues.
Yeah, that's right. I do affirm, but again, I don't claim to know, but I think that it is reasonable to express the hope that the life that finishes for us when we die and our body dissipates away is not necessarily the end of our story. Not because there's some non-physical thing which itself sort of captures who we are, but rather that God knows and can recreate who we are. It's more like that. I'll give a very mundane, but I hope helpful illustration. So on the World Wide Web today, you can find examples of microprocessors that were built in the 1970s or 60s. So the early computers. Most of the hardware there has now gone away, and you can't buy these computers anymore. But fans of the the Sinclair machine or the BBC Micro, the fan club has sort of performed a sort of resurrection. They've made other more powerful computers express through their operating system these earlier simpler devices. So it's sort of a resurrection. Again, this is a very mundane illustration, but that's the sort of thing which might convey the flavour of the idea.
Okay, thank you.
Well, and Andrew, we've kept you going now for a full half hour after your talk. I think it's time to bring the evening to an end. I'd like to do so with a series of thanks. First of all, to everyone who attended this evening, and especially those who have asked questions.
I'm not interrupting you.
Sorry, I'm just trying to. To everyone who's come this evening, and especially those who have asked a question. Secondly, like Andrew himself, I'd like to thank my colleague, Amelia Cross, who has done a wonderful job in organizing this evening, as she has every one of our series of webinars. But above all, Andrew, on behalf of us all, I would like to thank you very much. You took on what in some ways I think is arguably the most difficult of topics. And you led us very clearly through a series of very substantive and difficult subtopics, and then came out with really a very clear conclusion, which you then teased out and amplified and deepened by your generous and creative responses to the various questions that you were asked. I'm very grateful, and I'm sure your whole audience is, as is reflected in some of the comments we've already had in the chat. So thank you very much indeed. We're very grateful.
Thank you.